Thanks. Okay, so now we'll move on to macromolecules. Okay, this part of the chapter is kind of it's together with alkenes because macromolecules is kind of so we have an addition. It's kind of your polymerization chapter. Okay, so it involves addition, polymerization, as well as condensation. Okay, so what do I mean? There are two different types of macromolecules. Macromolecules just mean a molecule that is super long, not just like a one ethene monomer or something. We are talking about a very long chain that continues to react. They can keep on reacting and forming larger molecules. Okay, so what do I mean by that? First off, we look at something called the addition polymerization. This one involves your alkenes. Okay, why does it involve alkene? Because basically we just need one kind of monomer. Okay, it involves only one kind of monomer. So let's take ethene as an example. Okay, this is, if it's just ethene, it will form polyethene. Okay, so let's say we are looking at a ethene monomer. So ethene monomer will just react with a bunch of other ethene monomers. So what do I mean by that? Okay, let's react it with let's react 4 ethene monomers together. Once we do that, we can form a macromolecule. We can form a polymer already. Okay, so let's look at this case here. We got 4 monomers of ethene. We call one of them a monomer because they only one, so monomer. But if we add them together, it will be called a polymer. And in this case, because it's ethene, it will be called polyethene. Okay, so when we go through this thing called polymerization, what's going to happen is that we need catalysts, high temperature and high pressure. These are conditions, otherwise it won't happen. Okay, then what's going to form? So we have to see here is that this double bond is going to break. Okay, all the double bonds are going to break, and you know, right, when a double bond break, what's going to happen? It's going to form 2 more bonds. So once it forms 2 more bonds, right, it can join together to form a giant polyethene, something that looks like this. Okay, but you can see that at my ends, right, I have extra bonds at my ends, my 2 ends here. So they will just be left to react with more other polyethene molecule. Okay, so we leave it there.
How big must one be?
How big must it be? As long as you just react both, right? Once you react both, right, you can see that these 2 parts here will be out, free to react with any other molecule. That is already yes, that's already macro because it can continue. Okay, it will never just stay like that. Since it has free bonds, it can continue to bond with another monomer or another polymer, and then it will form something very large. Okay, so plastic is one of them. There's no limit. There's no limit. Yeah, there's no limit. But let's say they only give you 4, like in this case, then you can only react this 4. You can only show it by drawing 4 joined together. You cannot add additional because they only say 4. Okay, so what do I mean by that? Okay, so this 4, right? This 4 here, I can summarize it. I don't want to draw 4 of it out. I can summarize it by just writing it in this way. Okay, in this way, right, I do not need to draw out 4 monomers, which is quite time consuming. I just put a 4 in the front to indicate that I have 4 monomers with me, 4 ethene monomers with me. Then we write the same conditions and the arrow to indicate polymerization. Okay. And then how do we summarize this big polyethene here? We can actually just draw. You can actually just write it like that. Yeah. With 2 brackets. Okay, we just add 2 brackets at the side, and then we add a 4 because there will be 4 of this. Okay. Then this is my polyethene, and it's called a repeat unit. So remember what a repeat unit is. A repeat unit is actually a polymer already. Why you hold your scissors? That's so scary. Okay. Okay, so this is how we can summarize it as well. Okay, then any questions for your addition polymerization? Everyone quite clear? Okay, so addition, polymerization, what can they form? What can polyethenes form? Like your everyday products. Makeup.
Like
Cosmetics, okay?
yeah.
More commonly is plastics, like your Tupperware, all this. Okay, plastics, okay? Polyethylene forms, like common products are plastics. Okay, and then let's talk about condensation polymerization. Condensation polymerization, the difference here is that they don't have is that they are formed with two different kind of products, not just one. Okay, so we have one that is formed with ethanol monomer, alcohol monomer, as well as a propanoic, as well as a carboxylic acid monomer. In this case, we can see esterification happening, but in this case, it is forming a polymer. Okay, so what do we do is we take away H, remember, take away H from the alcohol and take away OH from the acid, which is going to go through polymerization and form a polyester. Okay, because you know your alcohol and carboxylic acid forms ester. So in this case, since it's going through polymerization, it becomes polyester. And don't forget your water product, because esterification always involves forming a water product. In this case, right, we have two ends. It has to have two ends with the same functional group. Otherwise, it will not form esters. Sorry, it will not form polyesters. It will not go through polymerization if there is only one side with the functional group. It has to have both side functional group. Okay, so when we are talking about alcohol and carboxylic acid, we call it a polyester, not polyethylene. Polyester can form something called pterylene, which is I'll put it here. Yeah. Okay. We can also do it. We can also summarize it. We can summarize it by writing it like that. Okay, with the N in front once again. Forming this repeat unit. Okay, remember this is called a repeat unit. It's a polyester, but it's a repeat unit. Okay. What other condensation polymerization can happen in this case? We can also form other than ester polyesters, we can form something called a polyamide. Okay, polyamide is not formed by alcohol and carboxylic acid. In this case, it's formed by carboxylic acid and amine. Amine is just something with NH2 functional group. So what do I mean by that? Amine monomer, right? It's kind of like ammonia have your NH3, but in this case it's amine, so it's NH2. Okay, we have NH2 at both sides. Then it will react with a propanoic, it will react with an acid lah. But let's say in this case it's a propanoic acid. Okay. Once again, for your acid, we always take away OH. Amine will, like your alcohol, only take away one H. Okay. Then your H and OH will form water product. Okay. And the rest is just going to form something called a polyamide. And don't forget to add your conditions as well. Okay. Or we can summarize it once again. Summarizing it means writing it something like that. Your monomer will have a number in front to indicate how many monomers you are react with. Okay. Polymer will just be a repeat unit with the number at the back. Okay. Then you can see that this here is called what linkage? Amide linkage. Okay, amide linkage. This is to indicate to you that you have a polyamide. You have a condensation polymerization. Over here we have when there is a COO here, then this is called your ester linkage. Okay, you can break this up to form your monomer. Okay. Okay, so that's it for macromolecules, and that's it actually for your whole organic chemistry. chapter. Okay, so everyone clear? Now we will head on to a Kahoot exercise. Which question was that? Can you send me a picture? Okay. Yeah, send to me. You need me to explain it. Okay, sure. Okay, so y'all can join. Yeah, like, just wait for the okay. Can scan or yeah. Okay. Okay, those that are in Zoom, y'all can also join the Kahoot if y'all want to. Okay, we also have online friends that's joining us today. Inhan, you join already? Can't join? Sorry, Han Ing.